Good day everyone! So in this video, we will teach you how to use logistic regression in Jamovi.
What is a logistic regression? How is it calculated? And most importantly, how are the logistic regression results interpreted? That's in this video. Let's start with the first question. What is a regression? A regression analysis is a method for modeling relationship between variables. It's possible to infer or predict a variable based on one or more other variables. The variable we want to infer or predict is called the dependent variable or criterion. The variables we use for prediction are called independent variables or predictors. But what is the difference between linear regression and a logistic regression? In a linear regression, the dependent variable is a metric variable. For example, salary or electricity consumption. In a logistic regression, the dependent variable is a dichotomous variable. What is a dichotomous variable? Dichotomous variables are variables with only two values. For example, whether a person buys or does not buy a particular product, or whether a disease is present or not. So with the help of logistic regression, we can determine what has an influence or whether a certain disease is present or not. For example, we could study the influence of age, gender, and smoking status on that particular disease. In this case, 0 stands for not disease, and 1 for disease. And the probability for the occurrence of the characteristic 1 is estimated. So our data set might look like this. Here we have the independent variables. And here the dependent variable with a 0 and 1. And now, we will show you a short tutorial about how to use the logistic regression in Jamovi.
Hey everybody, and welcome to another Jamovi tutorial. In this tutorial, we're going to talk about how to do a logistic regression. So here I already have data open, and we're going to jump right into the logistic regression analyses in just a second. What I want to remind everyone when they watch these videos is I always use the most recent build version for my operating system. And so right now I am using version 1.6.16. 1.6.16 released sometime in January, I believe, and I'm recording this in February 2021. So this is the latest build for macOS and for Windows, and it is fairly stable. It is the newest, latest build, but 1.6 itself is stable on both major operating systems. So let's jump right in. So here I have some data open, like I said, and I'm going to go ahead up to analyses to show how we're going to get this results going. And so when we want to do logistic regression, this is a situation where we have a number of predictor variables that are either dichotomous or continuous, but importantly, our DV is dichotomous. So we're going to have a 0 or a 1 as our dummy code for one of our for our two options, one or the other in this case. So how you do this is you go up to regression and you click on that, and here you have logistic regression identified here, and there are three kinds of logistic regression that you can do. We're going to focus on the more common two outcomes, which is a binomial output. And here you get the basic model fit measures and model coefficients that you would normally get for a regular regression, bivariate or multiple, that has a continuous dependent variable. So for this particular model, I am going to go ahead and put rent in as the dependent variable. And my predictor variables are going to be call grad. So if they are a college graduate, okay? And I'm assuming that you can do either covariates or factors here. Oh, I see. It is by type. Put call grad down there. So here we have the nominal icon, and here we have the scale icon. And so call grad is a nominal icon, whether or not they're a college graduate. 2, I'm going to put age, and I'm going to go ahead and put that in covariate there. And number 3 is going to be cell phone. I'm going to go ahead and put that in factor, and that's whether or not the interview was conducted with a landline or a cell phone, okay? And we can go into all of the various options here. So model builder, we can do a simultaneous or hierarchical logistic regression here. So I'm just going to do a simultaneous regression, okay? By the way, rent is 0 for homeowner, 1 for renter. That's why the variable is called rent. So in the positive direction from 0 to 1, so getting proportions larger, is more indicative of renting as opposed to homeowning. So that is what we'll do here. So I'm just going to leave the model as a simultaneous regression there. I'm going to leave my reference levels as 0 for each of the variable names, because that's the reference for the variable itself. So is it going to be 0 or 1? You can choose 0 or 1. 0 or 1. We'll leave it on default there, unless so I don't get too big. I would like to go ahead and get my collinearity statistics, my VIF and my tolerance for my assumptions to see whether or not it's bad. Fit measures, what you can see here is that deviance and AIC are checked by default, but we can also get BIC and overall model test, and then I'll add additional things to our output here. And then if we want to get pseudo R squared, we can get McFadden's R squared, Cox and Snell's. I might as well just get all of them to show you. And then Nagel-Kirk's. So we'll close that. Model coefficients. Let's go ahead and grab our likelihood ratio tests and our odds ratio and get 95% confidence intervals for our odds ratio. It depends on what you need for this, which is why they are not generally by default. But let's also get our confidence intervals for our log odds ratio. So let's go ahead and close that. Estimated marginal means. We are going to get all of them. So you drag over the terms and then you can get your marginal means for all three. So we'll go ahead and do that. We'll leave all of the default outputs for those marginal means, and then the prediction itself. Now you can have a cutoff point. So if you're trying to determine if the results are different from a binomial cutoff point, so this is using the binomial distribution, which is why this is technically a binomial test. We can also get different predictive measures. I am not versed in any of these predictive measures, so I'm going to go ahead and leave them off. You can also get an ROC curve or an AUC curve. I'm curious, and so I'm going to check. I have not used this data in logistic regression in Jamovi before, so I am curious what the ROC curve looks like here. So here we have our output. We have our model fit measures. So we get our deviance value, our AIC, our BIC, our pseudo R squareds, all three McFadden. I believe so Nagel-Kirk is the N, and then Cox and Snell's is the CS. And then we get a chi-squared, degrees of freedom for that test, and whether or not the model is p-value, what the model p-value is, and whether or not we will use that as significant. Now, our omnibus likelihood ratio test, so we get chi-square values for each of those, and whether or not those chi-square values are significant. And then we get our model coefficients. So we have our estimate for our intercept when all of these values equal 0. And then we have, so these are the unstandardized estimates here. And then we have a 95% confidence interval for each of those. We get a standard error for our estimate. We get a z value for these. Predictors, and whether or not those z values are different from 0, which would be a z value at the mean. And we get our odds ratio here, and then the confidence intervals for our odds ratios. Okay, and we get, like I said, we get our assumption check. So we get our VIF and our tolerance. They all look good. And then we get our estimated marginal mean plots here. So college grad, whether or not they are a renter. So college grad, less likely to be a college renter than a non-college grad, more likely to be a renter. And then we have the probability that rent equals 1 here for age. So and you can tell from this graph here, the older somebody is, the less likely they are to be a renter. And then the funny thing about cell phones and whether or not this survey was conducted on as a cell phone or not. So 1 would be cell phone, 0 would be landline. You can see that 1 cell phone, people are more likely to be renters than people who answered on a landline. And then here's the ROC curve. Oh, looks pretty good. Yeah, look at that. Specificity versus sensitivity. I like that. So overall, the data here is going to show you that the purpose here is to give more weight. How good is the model at predicting the homeownership based on college graduate status, age, and whether or not they took the survey on a cell phone or on a landline? And you can see here that with these values for the intercept and the 3 predictors, that they all significantly contribute to the likelihood that somebody would be a homeowner versus a renter. So college grad, age are negative predictors here. So you can see the negative here, and you can see their standardized z-scores are also negative. That means that as these values increase, so going from a non-college grad to a grad or increasing in age, you can imagine that the likelihood of being a renter is lower than if you were not a college grad or you were younger. Now, cell phone is a positive predictor, both in its unstandardized form and its z-score, significantly so. And this identifies the fact that you are more likely to be a renter if you answered or took this survey on your cell phone. And that is what you do for logistic regression in Jamovi.
And that concludes our tutorial. I hope that you have learned from our videos.